Hi everyone. Instead of giving you the answers to the day 7 homework, we're going to do the day 7 homework together. We don't have to. You should have done it ahead of time and check your answers with me. But I know this is a little bit of a difficult topic, so these will do. You can watch and do with me, or you can do it by yourself and then play the video back to see if your answer matches. Okay. The depth of the water in the bay can be modeled with an equation in the form d is equal to a cosine bt plus d. Automatically, we already know it's a cosine curve, so that means that if and when we sketch it, it's going to look, that's not how it's going to look. It's going to look from the top. There's no negative. Let's try that again. It's going to look like this because of the cosine curve, where t represents the number of hours since high tide and d represents the depth. The maximum depth of the water is 36 feet. Then the minimum depth is 22 feet, and high tide is hit every 12 hours. On the axis, sketch a graph of the scenario for 2 full periods. Label the points on the curve that represent high and low. All right, so a couple of things that we know from our word problem. The maximum is 36 feet. The minimum is 22 feet, and the high tide is hit every 12 hours. So that is period. It's asking us for us to graph 2 full periods, so we need to graph up to 24 hours. And then when we scale the x-axis, so 24, half of 24 is 12, half of 12 is 6, and we are going to go down in quarters because something significant happens every single quarter. And then we'll go from here. There, 12, 6, so this is going to be 18, that's going to be a 15, and that's going to be a 21. A little bit snug there, but it's okay. We'll see what those 2 cosine curves look like. Label the points on the curve that represent high and low tide. Determine A, B, and D in this model. Okay. Amplitude will be the 36 plus 22 divided by 2. So that's going to give us a 7. Oh, sorry. Oh, wrong one. Yeah, so 36 minus 22 divided by 2. So that's where we get the 7. 14 divided by 2 is 7. I'm sorry, the midline is going to be the plus. 36 plus 22 divided by 2. That will be 58 divided by 2, and that'll be the 29. So 7 is the value for A. 29 is the value for D. To find the value of B, we're going to use the fact that 12 hours is the period. We'll set that equal to 2 pi divided by V. Cross multiply, and we get B is equal to pi over 6, which is the same thing we got in the classwork that video that we just did. All right, and we can label that capital B. It doesn't matter if it's capital B or lowercase b. So the equation of the graph is the following. So y equals, amplitude is 7, cosine, the b value is pi over 6x, t. And then we have a vertical shift of up 29. That's our midline. All right, so our midline is at 29. Oops, let's scale the x-axis now. So 22 is the low. 36 is the high. 29 is the midline. And I like putting this in here lightly. I can't do it very lightly because of the pen, but you can. Okay, now we're going to graph 2 cosine curves because it asked us to graph 2 full periods. So cosine starts high. At 3 hours, we'll hit the 0, which is a 29. 6 hours later, we'll hit low tide. Every critical value, something happens. Something critical happens. At every quarter, something happens. So here's one cosine curve. We're going from one high tide to another high tide. The directions asked us to graph 2 full periods. There we go. 2 full periods representing the high tide and the low tide. Label points in the curve high and low tide. So this is the high tide. This is the low tide. Okay, that's question number 1. Question number 2. The possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum number of hours of daylight occurring in the winter solstice is equal to 9 hours, and the maximum hours of daylight occurring on the summer solstice is equal to 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? Let me fix this. All right. What is the amplitude? So we have minimum is 9, and we have maximum is 15. You need to be able to get that from the word problem. Max is 15, minimum is 9, and you want to find the amplitude. Amplitude is max minus the min divided by 2. So 15 minus 9 divided by 2. And 3. The amplitude is choice 3. Number 3, a spring with a weight attached stretches and contracts with time according to the graph below. The maximum length of the spring is 10 centimeters. So notice 10 is the maximum. At 2/10 of a second, and it is a minimum length of 2 centimeters at 6/10 of a second. If the equation of the graph is in the form of y equals a sine b times t plus d, find a, b, and d. Okay, so the amplitude is going to be the max minus the min divided by 2, which will give us the 4. So that's A. I can get the midline right away. 10 plus 2 divided by 2, and get that a 6. And we did get that from the graph too. So the 6 is the midline, and you can actually do your subtraction right on the graph. Okay, now we need to find the b value. Notice that the entire curve happens from 0 to 8/10 of a second. 0.8 is a period because we have an entire sine curve. It takes 8/10 of a second. So period is equal to 0.8. So I'm going to set 0.8 equal to 2 pi divided by b. And we'll cross multiply. So we have 0.8b is equal to 2 pi. Here's a good review of complex fractions. So b is equal to 2 pi over 0.8. But we can't leave it like that because there's a fraction in there. So let's review. 0.8 is 8/10. When we're dividing fractions, we keep the first fraction the same, change division to multiplication, and flip the second fraction. Notice we can reduce. 2 goes into itself once, 2 goes into 8 4 times. Then I have 10 pi over 4, which I can reduce that by 2. So we get 5 pi divided by 2 is the b value. So if I needed to, if I wanted to write the entire equation, I can, and we should. So y is equal to, the amplitude is 4, so it's 4 sine of 5 pi divided by 2 plus 6. And that's a nice ending for that question. On the back, we have a couple problems where we want to state the transformation for each, and then we are going to graph y is equal to 2 cosine x minus pi over 2 for practice. Number 4, A. First thing that's happening is that we are moving to the right 3. We have our amplitude is now 2, so it's steeper by 2. We have a reflection in the midline. That's y is equal to 4. And we have a vertical shift of up 4. So you want to make sure that it helps when you state the reflection is and y is equal to 4 because that's the new midline. So that negative is the reflection. Letter B, y equals 2 cosine 4x minus 3. We don't have a horizontal change, but we do have a frequency is now equal to 4. We have an amplitude is equal to 2, so it's going to be steeper. And we have a shift of down 3. Okay. So last question, practice graphing a shift of x minus pi over 2. So what we're going to do first, we're going to graph y is equal to 2 cosine x. And then the second thing we'll do, we'll shift everything to the right, pi over 2. Okay, so I'll do the 2 cosine x in gray. Oops, let's label. No change in frequency, thank goodness. 2 pi, pi over 2, 3 pi over 2. And we can label our scale 1, 2 that way, negative 1, negative 2. And this interval is telling us to make sure we graph it from negative pi over 2 all the way to 2 pi. So you want to make sure you keep an eye on those intervals. They'll tell you how much of the graph they want seen. So I'm going to switch over to gray. I'll put this in a gray box so that you know that it's going to be the gray graph that's going to graph the y equals 2 cosine x. Okay. So 2 cosine x means the amplitude is at 2. Sine curve, there's no vertical shift. So it's a holo graph. We're going to start high, 0, low, 0, high. So there's my cosine graph of 2 cosine x. I'm going to change over to blue. I'm going to shift everything over to the right, 90 degrees. So this entire graph is going to go to the right. So this point is now going to be at pi over 2. It's going to be height of 2 at pi over 2. Pi over 2 used to be at 0. It's now going to be at pi. Pi used to be at negative 2. Now negative 2 is going to be over at 3 pi over 2. 3 pi over 2 used to be at 0. We're going to shift it to the right, 2 pi. I can't graph anymore. I can, but I can't show it. I can't show it. It does. I do know that it's going to come up here, but I'm not actually going to graph it. So if I start connecting the dots, and I have a curve, I have to know what's going to happen. So here, I'm going to go back to my gray. If the sine curve does continue down here, so that negative pi over 2 gets shifted to the right 90 also, so we have a point to finish off our sine curve, or actually cosine curve. It looks like a sine curve because it shifted to the right. We talked about that in the notes, how the sine and cosine curve, they can be identical with a shift left or right. So the blue is your final graph. The blue is the final graph. It was the gray graph that got shifted to the right 90. And we actually need to include negative pi over 2. So I know with the pattern that it's going to come back down or come down and it's going to hit 0. I'm sorry, it's going to hit the low of negative 2 at negative 90. So here's my entire answer from negative pi over to 2 pi in interval of y equals 2 cosine x minus pi over 2. It's a little bit complicated. Chances are you're not going to have to graph this on the regions. They want to make sure that you do understand what the horizontal shift is. Okay, next time I'll talk to you is probably going over the day 8 notes. Hope all is well. And again, please let me know if you have any questions. Thank you.